Hello everyone, welcome back to our channel with the new start. In this video, I'm gonna discuss on a topic called number system. So as you all know, when it comes to our mind, number system is a very important topic from quantitative ability section, right? So without any further delay, let's get started. In a Hindu Arabic system, we use 10 symbols 0 to 9. So these numbers are called as digits to represent any number. This is the decimal system where we can use the digits from 0 to 9, right? So here 0 is called as insignificant digit, whereas 1 to 9 numbers are called as a significant digits. Coming to the face value and a place value of the digits in a number. Face value of a digit, it's nothing but the value of a digit itself irrespective of its place in a numeral. That means face value is unchangeable value. For here you can observe in the example 486729, the face value of 8 is 8, face value of 7 is 7, the face value of 6 is 6, and so on. And place value is nothing but a changeable value. That means it changes according to the change of its place. Here you can observe in the example classification of numbers. There are many classifications of numbers, right? So coming to the natural numbers, the number 1 2 3 4 5 and so on, which we can use in counting, is known as the natural numbers. So the set of all the natural numbers can be represented by n. Whole numbers, if we include 0 among the all the natural numbers, then the numbers are 0 1 2 3 so on are known as a whole numbers. Hence every natural number is a whole number, but the set of all the whole numbers is represented by letter W. Integers, coming to the integers, all counting numbers and then negatives including 0 are known as integers. So the set of all the integers can be represented by Z or a W. Here every natural number is an integer, but every integer is not a natural number. Positive integers, the set of I power plus is a set of all the positive integers. Positive integers and natural numbers are always synonyms. Negative integers, the set of I power minus is a set of all the negative integers. 0 is neither positive nor negative. So on is all the non-negative integers. Rational numbers, the numbers of the form like p by q. Here, as we know that p by q are the integers, right? So here p is not divisible by q and q is not equal to 0 are known as a rational numbers. It may also define in the form of any number that can be written in the form of a fraction form. So it's a rational number. This may also includes integers, terminating decimals and repeating decimals, as well as fractions. For example, as you see, like 3 by 7, 5 by 2, minus 5 by 9 and so on are the set of all the rational numbers. It can be denoted by letter Q. Irrational numbers are nothing but the any real number that cannot be written in the form of a fraction form. That is, it is quite opposite to the rational numbers, right? So the numbers which are both non-terminating as well as non-repeating decimals are called as a irrational numbers. The examples can be shown like absolute value of 10 by 3, 27 root 2 and so on are in the form of irrational numbers. Terminating decimals will have a finite number of digits after the decimal point. For example, you can take that 3 by 4 equal to 0.75, right? Again 5 by 4 equal to 1.25. So again 25 by 16 equal to 1.5625. So it's a decimal will have a finite number of digits after the decimal point. Coming to the repeating decimals. Repeating decimal that has digits that can be repeat forever. Example, you can see that 1 by 3 equal to 0.3333 and so on. Example, 1 by 3 equal to 0.333, right? So here 3 is always repeats forever. Non-repeating decimals is that neither terminates nor repeats. For example, you can take that root 2 equal to 1.41213563. So it is non-repeat. Coming to the real numbers, the rational and irrational numbers together are called as the real numbers. That is, for example, 13 by 21, 2 by 5, minus 3 by 7 and 4 by 2, etc. are real numbers. The set of all the real numbers is denoted by R. Even numbers, any integer that can be divided exactly by 2. For example, 2, 6, 0, minus 8, minus 10 are those numbers exactly are divided by 2 are known as a even numbers. Odd numbers, an integer that cannot be divided exactly by 2 is an odd number. That means 1, 3, minus 5, minus 7 and so on the odd numbers that cannot be divided by 2. Prime numbers, a prime number that can be divided evenly only by 1 or itself, and it must be a whole number and it's greater than 1. So example, 2, 3, 5, 7, 11, 13, 17, etc. are prime numbers. So all these primes which are greater than 3 are in the form of 6n plus 1, or else it may also 6n minus 1. So note down here, 1 is not a prime number, 2 is the least and only even prime number, 3 is the least odd prime number. Prime numbers are up to 100, and there are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. So there are only 25 prime numbers up to 100. Coming to the composite numbers, the natural numbers greater than 1 which are not prime are known as a composite numbers. The number 1 is neither prime or nor composite. The smallest composite number is always a number 4. So co-prime numbers, two numbers which have only 1 as a common factor, are called as a co-primes or relatively prime to each other. Example, 3 and 5 are co-primes. So here the important note is that there are many classification of numbers in this number system, right? So it's a easy way to remember. So natural numbers is equals to 1 plus prime plus composite numbers, whole numbers is equals to 0 plus natural numbers, integers is equals to negative integers plus 0 plus positive integers, real numbers is equals to rational plus irrational numbers. So here any two digit numbers is represented as a 10a plus b, where here a is the first digit and b is the second digit. So for example, you can take that 63 represented as a 10 of 6 plus 3, right? So the sum of its digit is equals to a plus b, the difference of this digits equals to a minus b. So similarly, if we take any 3 digit numbers, is represented as 100a plus 10b plus c, etc.